So I am Aditya Gaikwad. I am from Sanjani College of Engineering, Kopargaon, and Department of Mechatronics Engineering. So now I am studying in TY Tech, and now I am going to present the CI activity of digital signal processing, and the topic is digital image processing, and the domain is two-dimensional discrete cosine transform. So the first question is, what is image processing? So the image processing is an important application of a two-dimensional signal processing because of the developments of fast, low cost and power efficient embedded signal processors for real-time processing. Digital image processing is widely used in portable consumer electronics such as digital cameras and picture phones. Now, two-dimensional discrete cosine transform. So now see that what is two-dimensional discrete cosine transform. The discrete cosine transform consists of a set of basic vectors that are cosine functions. The DCT may also be computed with a fast algorithm such as FFT, comparing the DCT with the DFT, that is a digital Fourier transform. The DCT has advantage that the transform is real valued. It is widely used in audio compression algorithm. In this section, we expand it to 2D DCT, which represent an image as a sum of sinusoids of varying magnitudes and frequencies. 2D DCT and 2D inverse DCT, that is IDCT, are widely used in many image and video compression techniques such as JPEG and MPEG standard. So these are some formulas used to uh, calculate the 2D DCT of m by n image. The first formula is used as x of I k is equal to c of k summation of small m 0 to m capital M minus n summation of uh, small n 0 to capital N minus 1 x of m n cos 2m plus 1 I pi upon 2m cos 2n plus 1 k pi upon 2n. Here I is row which is value varies from 0 to capital M minus 1, and column k varies value varies from 0 to n minus 1, and xik is the corresponding density coefficient of pixels value x of mn. In our equation, the normalization factors are defined as c of I. When I is equal to 0, then c of I is 1 upon under root m, and otherwise under root 2 by m. Also for column that is c of k, the value for k is equal to 0 is 1 upon under root n, and otherwise under root of 2 by n. The two-dimensional DCT can be applied to the rows, and then the columns are started from columns to rows. For a typical image, most of the significant information is concentrated in a few lower, smaller I and k DCT coefficients. The 2D IDCT, that is inverse DCT, is defined as x of mn summation from I is equal to 0 to m minus n, and k is equal to 0 to n minus 1 c of I c of k x of I k cos 2m plus 1 I pi upon 2m cos 2n plus 1 k pi upon 2n. Most image compression algorithms use a square image with m is equal to n is equal to 8, where in last slide we see the formula. There we put m and n is equal to 8. For example, GPG image coding standards partitions the original image into 8 by n 8 by 8 sub images and processes these small blocks one by one. In addition, the original pixel values of black and white image are subtracted by 128 to shift the grayscale levels from the original range 0 to 255 to a symmetric range that is minus 128 to 127 before performing this DCT. So now this is the original black and white image of our example. Now we are going to see the example of how to process the image by using DCT. So example is as mentioned in above. In many image compression standards, the image is divided into 8 by n blocks, and the 2D DCT is computed for each block. The resulting 64 DCT coefficient are split into one DC00 and 63 AC coefficients, and then quantities coded and transmitted or stored. The receiver decodes the quantities DCT coefficients, computes the 2D IDCT of each block, and then reconstruct the single image for typical image. Many of the DCT coefficients with large indexes IK have values close to 0, and thus can be discarded without seriously affecting the quality of the reconstructed image. So this image, when we apply the DCT and IDCT operations, black and white image make into this image. The code for converting the image is saved into the our MATLAB software, that is example 1.m, adapted from help menu. Computes the two-dimensional DCT of 8 by 8 blocks into the input image, saves only 10 DCT coefficients with small indices IK in each block, and then reconstructs the image with the 2D DCT of each block in the codes. We use T is equal to DCT MTX8. This is the function we are going to use to obtain an 8 by 8 DCT transform matrix. If A is a square matrix, the two-dimensional DCT of A can be computed as T conjugate with A conjugate with T dash. This computations is faster than using the DCT two functions if we are computing a large number of small sub images. In the code, we also use the functions PLK, PROC to implement distinct block processing for image. We use a mask to keep only 10 DCT coefficient with the smallest indexes and clear other coefficients to 0, so they do not need to be transmitted or stored. So this is the process what we are going to do in image. Next, this is also formulas to the one dimensional n point DFT defined in chapter can be extended to two dimensional m and n point DFT as follows. So now this is image when we did operations of on 2D DCT block. This image comes under the picture. So for unit images, the data range for Y is 16 to 35, and the range for CB and CR is 16 to 40. The MATLAB function RGB to YCBR VCR converts RGB images to the YCBCR color space, and the functions YCBCR to RGB performs the reverse operation. Yes. So I am got this data from embedded signal processing with the micro signal architecture book by Wun Seng Gan Sen Yam Ko. Thank you.